We're going to be talking about polar versus nonpolar. A polar bond is a bond in which electrons are unequally shared and pulled toward the more electronegative element. A polar molecule has polar bonds that do not cancel. A nonpolar bond is a bond in which electrons are equally shared. So a nonpolar molecule has no net dipole. When we're talking about polarity, we have to remember the electronegativity trend. As we go across a period and up a group, the electronegativity increases. So a bond is shared electrons between two atoms. The atom that is more electronegative means that it will pull or tug the electrons towards itself. We have symbols used to describe this tug or this polarity. Partial positive is assigned to the less electronegative atom. The partial negative symbol is assigned to the more electronegative atom. And we have a symbol for dipole, and that just shows the direction of the greater electron density. Now this dipole has a positive tail end that goes on the less electronegative atom, and it also has an arrowhead that goes on the more electronegative atom. That's the symbols you use to describe the polarities of the bonds. Now, when you are describing the polarity of the molecule, you want to make sure to start off with the correct molecular geometry. So you're going to draw your molecule to show the angles. Let's look at a few examples. Let's describe the polarity of the carbon-fluorine bond and the hydrogen-carbon bond. And so this carbon might be part of a bigger molecule. We want to examine the electronegativity value. We're looking at carbon and fluorine. Fluorine has a larger electronegative value, so it means it's more electronegative. So the electronegative atom gets the partial negative symbol, and carbon gets the partial positive symbol. We also have to draw the dipole. The dipole tail will always be on the partial positive end and go towards the partial negative. So what this is telling us is that fluorine is the partial negative, and it will attract the electrons in that bond. So there will be a tug towards fluorine. Because there's a tug, that is considered a polar bond. Let's take a look at the carbon-hydrogen bond. So we are comparing carbon to hydrogen. Carbon has an electronegative value of 2.5 and hydrogen has a value of 2.1. When you subtract 2.5 minus 2.1, you get a small value of 0.4. 0.4 is a small value, not enough for a very large tug. Because that value difference is small, we consider this a nonpolar bond. A nonpolar bond does not get assigned any partial positive and partial negative symbols. So carbon and hydrogen are sharing their electrons equally. Let's take a look at another example. Let's take a look at an HCl bond and a Cl-Cl bond. Between hydrogen and chlorine, chlorine is the partial negative element, and hydrogen is my partial positive. So the dipole is going towards chlorine. So chlorine is tugging, attracting the electrons in that bond. So there is a bit of a tug towards chlorine for that bond. Chlorine has a electronegative value of 3.0, and chlorine has an electronegative value of 3.0. So the difference, 3.0 minus 3.0 is 0. That tells us that chlorine is sharing its electrons with chlorine. There isn't a tug or an attraction for those electrons unequally. They're both sharing equally. because they're sharing equally, we don't use those symbols to describe polarity because this is a nonpolar bond. All of the diatomic molecules that have one element are going to be nonpolar. H2, Cl2, O2, F2, all of these diatomic molecules are going to be nonpolar molecules. Let's take a look at another example. Let's talk about a tetrahedral molecule. So we have carbon, and another tetrahedral molecule with different elements. All right, we have the correct geometry. Now let's examine the electronegativity. We said that carbon and hydrogen do not get assigned any symbols because that's considered a nonpolar bond, but carbon and fluorine have different values. So I'm going to go ahead and assign the partial negative on fluorine and partial positive on carbon, and I have to do this with every bond. Then I'm going to go ahead and draw the dipoles. So this is showing us that fluorine is attracting the electrons from carbon. And it's attracting at a 109.5 degree angle because it's a tetrahedral molecule. So I have this fluorine tugging at the electrons, and I also have this fluorine tugging at the electrons. So if you can imagine that center atom is getting tugged towards the fluorine atoms. So this molecule is considered polar. Let's take a look at the nonpolar molecule. CH bonds are considered nonpolar, so they don't get assigned the symbols. So there isn't a real unequal share or a big tug that we have to assign symbols. So the CH4 bond is tetrahedral, but it is also considered a nonpolar molecule. Let's take a look at another example. Let's talk about a linear molecule. So we're going to take a look at the carbon and the oxygen. Oxygen is more electronegative, so it gets the partial negative. And let's talk about the carbon and the sulfur. Carbon and sulfur have the same electronegative value, so they are not fighting or sharing the electrons unequally. They are considered to be sharing the electrons equally. So I don't have to assign any symbols on the carbon S bond. So I also have to go ahead and draw my dipole. And this is showing me that the electrons are the oxygen is attracting the electrons from carbon. So there's a bit of a tug in that molecule. That is considered a polar molecule. Let's take a look at carbon and oxygen in the CO2 molecule. Between carbon and oxygen, oxygen is more electronegative, so it gets the partial negative symbol, and carbon gets the partial positive, and I do that to all the bonds. Then I draw the dipoles. So what this is telling me is that this oxygen is tugging at the electrons at a 180 degree angle towards the left, and this oxygen is tugging the electrons from carbon at a 180 degree angle towards the right. So those dipoles are getting canceled out. If you try to imagine this center atom really does not get pushed in any direction because the opposite dipoles get canceled out. So the CO2 molecule is considered a nonpolar molecule. Good luck and keep practicing.